Artificial intelligence has become a central theme in modern manufacturing discussions, appearing in high-level meetings, scholarly studies, and strategic plans. Yet, integrating AI into manufacturing processes for consistent outcomes is complex, primarily due to long-standing disparities between management and operational levels. These gaps, especially in communication and understanding, pose significant challenges. Executives envision innovation and efficiency, but translating this vision into actionable plans is difficult. Operational staff, closer to production processes, often have valuable insights that aren't effectively communicated upwards. A critical area where these gaps are evident is in the integration of advanced technologies like Programmable Logic Controllers, or PLCs. Effective use of PLCs requires deep understanding of hardware, programming languages like ladder logic, and industrial processes. Without proper training and communication, PLC potential is underutilized. Moreover, PLC programming is a specialized skill, demanding comprehensive training and continuous education. Manufacturers must invest in upskilling their workforce to program and maintain PLC systems effectively. This includes understanding proprietary software environments and troubleshooting control systems. Adding AI to these control systems introduces another layer of complexity. AI can enhance PLC functions through predictive analytics and autonomous decision-making, but seamless integration with PLC systems is technically challenging. It requires robust infrastructure for data flow between systems and accurate AI model interpretation of data. Manufacturers need a holistic approach, acquiring the right technology and fostering a culture of continuous learning. Employees at all levels must engage, from PLC programming basics to AI and machine learning principles. Consider a manufacturing plant implementing an AI-driven optimization system. The process starts with assessing current PLC systems and identifying AI value areas like predictive maintenance or production schedule optimization. Workforce training is crucial, involving workshops, online courses, or educational partnerships. The implementation phase requires collaboration between IT specialists and operational staff, with regular feedback loops for AI system performance adjustments. In conclusion, AI integration in manufacturing is promising but challenging. Addressing organizational gaps and investing in training and infrastructure can unlock AI and PLC systems' full potential, leading to more efficient, reliable, and innovative production processes. To grasp the complexities of integrating AI in manufacturing, it's crucial to understand the role of programmable logic controllers, or PLCs. Think of PLCs as the brain of industrial automation, responsible for executing control functions and monitoring processes. They're essential for automating tasks, ensuring consistency, and optimizing production efficiency. But here's the catch: effective utilization of PLCs demands a thorough understanding of both hardware and programming languages like ladder logic. Without this knowledge, the true potential of PLCs remains untapped. It's not just about having the technology, it's about knowing how to harness it. This is where comprehensive training becomes indispensable. Manufacturers must invest in upskilling their workforce to ensure they can program, maintain, and optimize PLC systems. This includes mastering the proprietary software environments used for programming and being adept at troubleshooting and enhancing control systems. To harness the full potential of PLCs in manufacturing, specialized skills are essential. Imagine a PLC as the brain of a machine, interpreting data and making real-time decisions. To program it effectively, you need to master languages like ladder logic or structured text. This involves understanding not just the syntax but also the industrial context in which the PLC operates. Consider the interface, often proprietary, where you'll spend most of your time. You'll need to be adept at troubleshooting, optimizing control systems, and ensuring seamless integration with other technologies. This is where continuous education plays a pivotal role. Regular training updates are crucial, as the industrial landscape and PLC technologies evolve rapidly. Think of it as keeping your programming skills sharp and relevant, much like a craftsman refining their tools. And here's why that matters: without these specialized skills, the sophisticated capabilities of PLCs remain underutilized, hindering the overall efficiency and innovation in manufacturing processes. The integration of AI with PLC systems is a game changer, but it comes with its own set of challenges. First, consider the data flow. AI algorithms require vast amounts of real-time data to function effectively. This means your PLC systems must be capable of collecting, processing, and transmitting data without interruption. Imagine your PLC as a data warehouse, constantly feeding information to the AI. The trick is to ensure that this warehouse is well organized and that the supply chain, your data pipeline, is efficient. Next, think about the interface between AI and PLC. This is where the magic happens, but also where things can go wrong. You need to establish a robust communication protocol, often using OPC UA or Modbus. Set the timeout parameter to 500 milliseconds to ensure reliable data exchange. If you encounter error code 8001, it typically indicates a loose connection or outdated driver. Addressing these nuances will make your integration seamless and efficient. To effectively integrate AI into manufacturing, a comprehensive strategy is essential. Begin by evaluating your current PLC systems and pinpoint areas where AI can add value, such as predictive maintenance or optimized production schedules. Next, invest in training your workforce. This means workshops, online courses, or partnerships with educational institutions to build the necessary skills. During implementation, foster collaboration between IT specialists and operational staff. Establish regular feedback loops to ensure AI systems perform as expected and make necessary adjustments. Remember, the goal is to create a culture of continuous learning and adaptation, engaging employees at all levels in the technology integration process. To successfully implement AI-driven optimization systems in manufacturing, a structured approach is essential. Begin by conducting a thorough assessment of your current PLC systems. Identify specific areas where AI can add value, such as predictive maintenance, production scheduling, or quality control. Next, ensure your workforce is equipped with the necessary skills. This could involve targeted training programs, workshops, or partnerships with educational institutions. During implementation, foster close collaboration between IT specialists and operational staff. Establish regular feedback loops to monitor AI system performance and make necessary adjustments. Remember, the key to unlocking AI's potential lies in bridging organizational gaps and investing in continuous learning and robust infrastructure.